Hey everyone, welcome to this explainer. Building a CAPTCHA integration inside an Encore.Go microservice, it's usually the easy part, right? Getting that initial code running feels pretty smooth, but keeping it reliable in a production environment, yeah, that is where most teams hit a wall. If your automation is running in scheduled jobs, worker pools, or any unattended services, just a few tiny implementation mistakes can easily trigger a cascade of failed workflows, rejected tokens, and honestly, hours of debugging. So today, let's dive into a highly practical checklist to get this fixed. Think about it. In development, you're cruising on the happy path. You submit a task, boom, a token comes back, and you're wrapping up in 5 minutes. But production introduces a much more chaotic reality. We're talking about network interruptions, aggressive retry loops, and configurations that suddenly change without warning. Those simple development demos just don't reveal these kinds of pressures. Here is our roadmap for today. We'll be walking through the trap, the checklist, the metrics, the mistakes, and finally, safety. Let's jump right in. Part 1. The trap, or why demos fail in production. The source material lays down this fantastic baseline. What you actually need is predictable, solve latency, clean failure modes, and code that another developer can raid in 5 minutes. When a job runs completely unattended, it has to be tough. It needs to survive deploy windows and random network hiccups. If your code just aggressively hammers an API the second something goes wrong, well, you don't really have a clean failure mode, do you? You have a fragile integration. Moving on to part 2, the checklist. This is how we build a bulletproof workflow. To get there, you absolutely need a consistent workflow lifecycle. Basically, you want to keep every single request moving through this exact rigid sequence. Capture the inputs, submit the task, wait and poll, apply the token, and then record the outcome. Treating this whole process as a strict, non-negotiable pipeline really prevents those weird edge case errors and makes maintenance vastly easier for your team. Now, right out of the gate, before you even send a task off to the service, you absolutely must validate your request inputs. Why? Because capturing the wrong parameters creates a completely false debugging trail before the solver even does anything. You do not want to spend 3 hours tearing apart your codebase just to realize the problem was a malformed URL. Which brings us to what we call the same session handoff. This is arguably the most crucial step of the entire pipeline. Once that CAPTCHA is solved, you have to apply the token in the exact same browser context, HTTP client, and cookie jar that triggered the challenge in the first place. Seriously, mismatched sessions are the single most common cause of post-solve rejections. Okay, let's talk about polling. Polling too much just adds network noise, while polling too little slows your whole operation down. A really smart strategy looks like this. Wait exactly 15 seconds before your very first poll, then poll every 5 seconds, and finally, you have to implement a hard cap of 120 seconds per task. Setting that limit ensures your microservices don't just hang there indefinitely. Next up is your retry budget. Look, retries are meant to help you recover from temporary hiccups, not to mask permanent defects in your code. So cap them at 3 attempts and always use exponential backoff. Infinite retries will just silently burn through your account balance and obscure the real problem. You're basically DDoSing your own wallet at that point. All right, part 3, tracking production KPIs, or how we actually measure success. I highly recommend wiring these specific targets directly into your application dashboards. First, look at your first solve latency for the 50th percentile. That means half your tasks should finish faster than this target, under 25 seconds for a token, or under 8 seconds for image OCR. If you're hitting that, your integration is pretty healthy. Next, your solver success rate needs to be 95% or higher. And critically, your end-to-end acceptance rate also needs to be 95% or higher, which proves that your same session handoff is actually working the way it should. Now, here is a crucial distinction you need to make. There is a massive difference between solver success, meaning the API actually returned a token, and end-to-end acceptance, which means the downstream server actually accepted your workflow. Raw solver success is completely meaningless if the downstream verification ultimately fails. Remember, a solved task does not equal a successful workflow. So track both of these and set up alerts for your team if a gap starts opening up between them. Part 4. The mistakes. Let's go through a quick troubleshooting FAQ. Let's quickly review the most common developer anti-patterns. These are the things that actively erode your profit margins and destabilize your backend. We're talking about wrong request inputs, session mismatches, overpolling noise, infinite retry storms, and just straight up ignoring end-to-end monitoring. Avoiding these exact pitfalls is what separates a mature, robust microservice from a fragile, hacked-together script. So let's look at the most frequently asked support question when developers integrate these workflows. They always ask, why is my solve token rejected? You get the token, you send it off, and the server just says, no. Why does that happen? Well, as we touched on just a minute ago, the immediate one-line fix is almost always related to your session state. The token was applied in a different browser context or HTTP session than the one that originally triggered the challenge. If you keep the challenge and the token submission tightly bound inside the exact same session, this problem usually just disappears instantly. Here is another great question for future-proofing your integration. What happens when the site you're automating against suddenly changes the CAPTCHA family they are using? Do you have to scramble and rewrite your entire microservice? If you're using a unified API, the answer is no, absolutely not. You simply swap out the task type parameter in your code, but you keep the exact same submit and pull loop. Because a good API exposes a single unified structure across all CAPTCHA families. Different types can be supported with incredibly minimal code changes. It makes long-term maintenance an absolute breeze. Finally, part 5, safety and maintainability. It is so absolutely critical to remember that these workflows must only be used in authorized environments. We're talking about applications that you actually own, environments where a client has explicitly authorized the integration, or scenarios involving contractually permitted data collection. This explainer is absolutely not a recipe for circumventing protections on third-party sites where you have no agreement. You gotta keep your automation inside a safe, fully authorized scope. As the source material so perfectly points out, reliable CAPTCHA automation isn't just about solving challenges. It's about building workflows that remain stable, observable, and maintainable. True engineering maturity isn't about finding a quick hack. It's about building a system that gracefully handles inevitable failures as your microservices scale. So I'm going to leave you with this thought to chew on. Are your automated microservices actually completing successfully? Or are they just hiding permanent failures behind unlimited retry storms? Seriously, go check your logs today. If you found this checklist useful, make sure to explore the full Encore Go CAPTCHA integration guide for more implementation details and production best practices. Thanks for joining me for this explainer, and happy building.